So we're really glad to have an expert speaker today for our Vermont Vegetable and Berry Growers webinar. Christy Hoepting from Cornell Cooperative Extension is here to talk about onion and all the rots and all the awesome smells that come along with the job. So I'm going to hand it
Mhm.
over to you, Christy. Thank you so much for joining us.
Thank you for inviting me. So yes, I'm an onion specialist, and in New York, I mostly work with large scale conventional muck onion production. Um, but I also have worked with small farm production as well, sweet onions and small scale onions. So I think I have something to contribute. So for this presentation, I'm gonna talk a little bit about onion thrips, and then the main leaf diseases: Botrytis leaf blight, Stemphylium leaf blight, downy mildew. But really the emphasis of this presentation is going to be on bacterial bulb rot. And I was fortunate enough to be a part of a very large USDA multi-state, multidisciplinary, multi-year, multi-million-dollar project, which is just finishing up. And we have affectionately called it the Stop the Rot Project. So I'm going to share some research results from that project that are relevant that can be relevant as well. And I'm going to finish with harvest practices for best quality. And some of this relates back to bacterial diseases as well. Okay, so I'm going to start with onion thrips. So this is a close-up of the adult and the larvae. So I never see them in this detail. In real life, they look like about a 1 millimeter, just little sliver of yellow, or the adults are a little sliver of brown. And they are cosmopolitan pests. They have multiple hosts. They do love onions. And I always say, I don't care who you are, where your onions are, thrips are going to find your onions. But they're very tiny, so you have to look for them. And they have rasping, sucking mouth parts that slurp up the chlorophyll of the leaf. So when the leaves don't have chlorophyll, they can't convert sun into energy into food. So we have seen like 60% reduction in bulb weight because of thrips feeding. And here on the right, you see a photograph of a plant that has had a lot of thrips feeding, that silvery type, I don't know how you describe it. But when you're at this stage, you've already had a yield reduction and a thrips population that, likely with organic insecticides, you cannot control. So you have to start managing this pest early. And it's favored by hot and dry seasons. There's multiple generations per year, 3 to 6. In New York, we typically start to see the thrips in early June, sometimes into May even. I'm assuming in Vermont it's probably very similar. So you want to start looking for them, especially in transplants around the end of May, beginning of June. And so they're going to, at first they're going to be in the leaf axils, and you should be able to see them here. You're going to flip through all these inner leaves and count the number of thrips, count the number of thrips per leaf, and then you take the number of thrips that you count divided by the number of leaves, and that should give you the number of thrips per leaf. And so the spray threshold for organic insecticides is 0.5 to 1 thrip per leaf. That's when you need to start your spray program. And your goal is that the average number of thrips per leaf across the season is going to be 2.2 or less. Above that, yield reduction may occur. And truthfully, if you've got high thrips pressure with the insecticides that we have, the organic insecticide options, you probably are going to experience some yield loss. We don't have anything that's strong enough to really control that thrip population. And I put this slide in here. The thrips on here are insane. This is probably like 100 thrips per leaf or something like that. But I put it in here because they will move up from the leaf axils onto the leaves. So later in the season, if you're just checking leaf axils, you're like, oh, I don't see any thrips. But you have to look at the leaves as well, because thrips could be there as well. So my colleague, Dr. Brian Nault, he's the onion entomologist at Cornell. He's supposed to work on other vegetables, but onions are his favorite. And then he had a postdoc, Lindsay Iglesias. I can't remember exactly when this was done. I want to say like 3 or 4 years ago. Time flies. But anyway, they looked at varieties and mulch types and by far, organic insecticides are the most effective means of controlling thrips in organic onion production. The best treatment in that trial was Entrust plus Impede. And so Entrust you should be familiar with, that's spinosad. Impede is an insecticidal soap that also has insecticidal, fungicidal, and miticidal properties, but it caused phytotoxicity. So we don't want to recommend that. The second place was Entrust plus Trilogy. Trilogy is it's a neem oil, I believe, which also it acts as a penetrating surfactant. It also has insecticidal, fungicidal, and miticidal activity. It did not cause phytotoxicity, and it resulted in 76% control. And that's when they're starting their spray program, when the thrips are no more than 1 thrip per leaf. So basically, they're stacking products because single products aren't effective enough. But the thing is, you don't want to be spraying Entrust all season long because it is subject to insecticide resistance, and at the maximum rate per use, you can have up to 4 applications per season. So Brian is recommending to rotate it with Nemix, which is an azadirachtin product, plus New Film P, which is an organic spreader sticker. That is what I call in the category significantly better than nothing but not great. But we just cannot be using Entrust season long, so he's suggesting to rotate with that. And the way that we rotate for thrips is 2 weeks in a row and then rotate to another product, because that life cycle or single generation is about 2 weeks. We don't want to subject multiple generations to the same active ingredients, and this is just resistance management. Okay, botrytis leaf blight. This is probably the least the disease of least economic importance. It has 2 phases. The first is what I call halo lesions. It's not just me, I didn't make that up. People call them halo lesions. And they are a tiny little straw-colored necrotic spot surrounded by a silvery halo. Sometimes if there's not enough leaf moisture, you just see the silvery halos. The necrotic spots are hard to see. These leaves are peppered, and when they age, the necrotic centers split or enlarge, and the halos can become sunken. And this phase of the disease expresses itself on young and healthy tissue earlier in the season. And to see this level of disease, I don't see it that often. But when it's this high, you could get excessive leaf dieback that potentially could affect yield. Then the second phase of the disease is necrotic spots. So they can be pinprick in size all the way to 1 to maybe 3 millimeters at the largest. And they're very yellow when they're small, and they can become more white in color when they're older, and they express on older, less healthy foliage. So we see a lot more on the leaf tips and certainly on the older leaves. These are examples of plants that are absolutely peppered. And yes, when the disease is this high, it causes excessive leaf dieback, which can affect yield.
Hey, Christy.
Yeah.
So I know some growers have trouble telling the difference between thrips damage sometimes and the botrytis leaf spot. So, but botrytis leaf spot would probably be after cool, wet conditions, right? But the thrips would be more hot and dry.
Well, truthfully, you can have both of them.
Both. Okay.
Oh yeah, like we're counting spots through thrips damage.
Okay. All right.
So the spots are defined spots. I guess I find the halos, they just catch the light in a certain way. They pop to me. The thrips is more of a just, how would you, a streaking?
Okay.
Maybe would be a better way to describe it.
Right.
Right. Yeah, and I could probably provide you with a close-up of thrips feeding compared to the necrotic spots and the halos. I'm sure I've written an article and I've got it. So this graph, never mind all the different detail in it, but basically we're chunking out June, July, and August, and the black line is the halo lesions. So we're seeing them the second half of June, peaking mid-July, and then when the plants start to get older, they drop off, and then at that time we have low levels of necrotic spots in July, but then they really jump up through the end of August. So for a sweet onion variety, unless conditions are really favorable, I don't think you're really going to be seeing this surgence of necrotic spots. Moving on to Stemphylium leaf blight. I didn't even spell it out. Stemphylium leaf blight is SLB. Purple blotch can go in this category as well. Truthfully, both of those diseases can run in the same field or the same planting and on the same plant. Visually, they both cause tan, black, or purple lesions. You cannot distinguish, it's hard to distinguish them in the field. In the muck fields, Stemphylium totally dominates over purple blotch. We hardly ever find purple blotch anymore. In organic production, we do see both. For the purple lesions, purple blotch can be more pinkish, magenta, really, really pretty. So sometimes I'm like, I think this is purple blotch, and I send it in, and yes, I was right, it was purple blotch, and it was a really, really beautiful, pretty lesion. Stemphylium maybe are not as pretty, but it, you know, they're hard to distinguish. When Stemphylium can act both as a primary or as a secondary disease. When it's secondary, it's invading tissue that was already necrotic. It's hanging out there. It doesn't seem to be really that interested in causing too much trouble. When it's primary, it's acting as an aggressive pathogen. It's infecting new foliage and it's causing leaf dieback. It's causing trouble. So when it's primary, you will see black spores on the target spots in the leaf tips. Anytime you've got target spots associated with this greasy, water-soaked tissue, if you've got any color of target spot on otherwise green leaf tissue, and if you've got those showy purple-black lesions and excessive leaf dieback, this disease is primary and it's causing trouble. We also, in addition to the targets, we also see sporulation or invasion of the necrotic leaf tissue when the leaves start to die back on the tips and the outer leaves. It expresses itself tan in color, and then you can also see black spores. It looks, I call this dirty tips. It just looks like the tips of the onions are dirty. They're not clean. And both of these diseases are, or all of them, botrytis, Stemphylium, purple blotch, when they are severe, they can cause excessive leaf dieback. If you've got 30% or more dieback at the time that the plants are start to lodge and you can't control that disease, they can go on to die standing up. And I'll talk more about that momentarily. Here's a picture of excessive leaf dieback from Stemphylium in organic sweet onions, and you can see how black the spores are on those leaf tips. And I thought this was downy mildew. So speaking of downy mildew, let's talk about downy mildew. So for us in downy mildew, this is a sporadic disease. We don't see it every year. It's favored by cool temperatures and long periods of dew. So the risk period is from mid-August through September when we're getting those long periods of nighttime dew, and especially in varieties with long days to maturities that are still green during that time. So when it comes in late, it's usually not too much of a problem. When it's a problem is if it comes in July or if it comes in August, and you've got beautiful green foliage, and I have seen it take out a crop in 2 weeks straight. So the first sign of downy mildew is just that fuzzy gray sporulation, usually in the middle of the leaf, in a middle-aged leaf. And this stage of the disease, I gotta say, is often missed. It attacks green tissue and then it kills it. So then there's a necrotic spot, and then that's invaded by Stemphylium or purple blotch. So you can see it at this stage. And sometimes that purple or the sporulation is overlooked. But if a grower finds it at this stage, it's already 2 to 3 weeks old, it's already been cycling, and then the Stemphylium, which is such an aggressive pathogen, you're dealing with a complex, and that's what ends up taking the onion foliage down. And then here's just a visual of, this is a conventional field, like even conventionally with our good fungicides, we can't control this complex. So unfortunately, I don't have any great recommendations for controlling Stemphylium purple blotch or downy mildew organically. The only fungicide, I've been doing a lot of work with Stemphylium particularly, the only product that has any, I'd say, mediocre activity, mediocre to poor, is a product called Oso. There's a generic version of this called PhD. It's a Frac 19. It's a polyoxin D, zinc, something like that. I'm botching the active ingredient. It's expensive. It may help a little bit, but when I put this product out by itself, the onions are dying standing up by the end of the season. So unfortunately, that's all I have by that. You're at the mercy of Mother Nature, but we could talk about how else we may manage harvesting a crop like that's gone down with severe disease. Okay, so now I'm going to move into bacterial bulb rot. So one of the objectives of the Stop the Rot project was to figure out what kind of rot we got. So we submitted samples, foliar samples from the field, and then symptomatic bulb samples, and they analyzed it down to genre. So nationwide, okay, first of all, I'll say they pulled out over 100 different genera. Never mind the number of species per genre, just over 100 genera of bacteria were pulled out of plants, asymptomatic plants of bacterial disease. That's crazy. So the most common genre of bacterial diseases of onion nationwide: number 1, Pantoa; number 2, Pseudomonas; number 3, Burkholderia; number 4, Enterobacter; number 5, Bacillus. In New York, we are dominated by Burkholderia. Same thing in Pennsylvania. Several species of the same genre, several genera are often found in the same bulb, and it's difficult to distinguish what causes what. Truthfully, a lot of them are running together. For the most part, it doesn't matter what kind of rot you got. Management strategies are very similar. I will point out when what kind of rot you got may make a difference. So for the Stop the Rot project, we actually my team put together a 4-minute diagnostic video to help you distinguish bulb rot caused by bacterial diseases versus fungal versus abiotic factors. Conventionally, if it's caused by fungal, you'd want to manage that with fungicides. If it's caused by bacteria, fungicides are not going to help you. So that's a really quick, easy video to help you out. Now, in the disease, looking at foliar symptoms, in my experience, they kind of look 2 different ways. They're either white or bleached leaves or yellowish brown and water soaked. Either way, it's a middle-aged leaf that starts to go down, a single middle-aged leaf that starts to go down. Then the middle-aged leaf on the other side goes down. Eventually, multiple inner leaves go down, and you end up with a total collapse of the foliage. And then at harvest, you can have all of these different stages. You can have the onions in all of these different stages. And the majority of the symptoms show up in the field after bulbing. Every now and again, we do see bacteria before bulbing, but for the most part, it's after bulbing. So again, the Stop the Rot project, my team developed a 4-minute diagnostic video, how to diagnose symptoms in the field and distinguish them from other lookalikes. Okay, talking the basics of the bacterial disease life cycle. So what you need to understand how this disease works. So first of all, the bacteria live in the soil and they infect the onion leaves predominantly in the neck region. The bacteria come in contact with onion leaves or the neck region via splashing soil, wind blasting, sideways rain, cultivation, anything you can think of that's going to get the contaminated soil into the neck region of the plant. You can have plant-to-plant spread, but during harvesting by contaminated knives or snippers, whatever it is you use to top the onions. And then bacteria can also enter through wounds, most commonly hail injury, but anything you can think of that may damage that succulent green foliage. It's just a wide open door for bacteria to come into. Onion plants are most susceptible to bacteria disease between early leaf senescence, so that's when it's about 5% tops down or lodging, to 50% tops down. And that is when the necks have reached their full size, but they're starting to lodge, or they're starting to soften, they're preparing to lodge. And they're still, so the neck, when it's soft like that, it's not as tightly sealed, and it's more susceptible to infection by bacteria. It's easier for the bacteria to get in. And also the onions are still standing. So if there's rainfall and there's pooling of the water in the neck area and the leaf axils, that just creates an environment that's more favorable for infection of spread. And you can have very thick canopies at that time. So poor aeration, longer periods of leaf wetness. So free moisture is critical for infection spread and disease development. And often diseases are favored by warm or hot temperatures. There's a few that run under cooler temperatures. So the disease is going to spread down the leaf, through the neck, and into the bulb. It spreads in green tissue because it needs moisture. And fun fact, onion bulbs have antimicrobial properties, so not all of the bacterial strains can even survive inside the bulb. So just because you have a lot of foliar symptoms doesn't mean that all of that disease is going to end up in the bulb. So when you see different foliar symptoms and you cut down the plant longitudinally through the neck, often it's not into the bulb yet. So just to illustrate the importance of moisture for driving bacterial disease, this is a project that was done for the Stop the Rot project in Tule Lake, California, with sweet onions, and they compared overhead irrigation to drip irrigation. And they started irrigating at the 6-leaf stage, ran it through the end of the season according to the needs of the crop. So both treatments got the same amount of irrigation. Overhead irrigation had 22% rot, which was significantly reduced by 97% to less than 1%. This is the most significant reduction in bacterial rot of all of the projects that were conducted in the Stop the Rot. And it just illustrates again how important moisture is for driving this disease. So small scale onion production, if you can use drip irrigation, use it. Obviously we are at the mercy of Mother Nature, and sometimes she's just going to deliver what I call rot rains. Okay. In-season management of bacterial diseases. Can you spray your way out of the problem with bactericides, plant defense activators, sanitizers, biologicals? So as part of the Stop the Rot project, in 9 different field trials, actually, I think this needs to be updated. I think even more trials have been done since I put this slide together. But in 9 different trials across multiple states, all of these different products have been tested. I highlighted in blue which ones I tested personally. There was never a significant difference between the untreated and any of these products. Nothing works. They can't get to the neck area where they can't target the neck area where the disease needs to be controlled. Furthermore, 50% of the Pantoa agglomeratin strains sequenced to date carry genes that make them resistant to copper. So that's why copper bactericides don't work, because the pathogen is resistant. And my colleagues in Pennsylvania have been looking at strains of Burkholderia collected in New York and Penn State. They also are carrying strains that make them resistant to copper. Furthermore, copper plus adjuvants plus high temperatures in the 90s, in the 100s, resulted in phytotoxicity. So if you've ever seen anything like this on your onion foliage, this is phytotoxicity. This is not a disease. It's caused by a hot tank mix. So Cornell, myself, we are no longer recommending bactericides to control bacterial diseases of onions. They don't work. Okay, another in-season management strategy. This is work that I did in 2010. So this has been out there a long time. We've seen a lot of growers adopt these practices already. But basically, black plastic creates a very hot microclimate. And when the bulbs are bulbing, they really wrap themselves around the onions. It makes it very, very hot around that onion bulb. So if we can, just by getting onions off of black plastic and putting them on reflective silver mulch, which creates a cooler microclimate, biodegradable black plastic, or bare ground, we significantly reduced bulb rot. These were sweet onions by 59 to 75%. Similarly, the silver and the biodegradable black plastic increased yield by 3 times. And then we did not weed our bare ground plots, so there was a bit of a yield reduction there, but we did reduce the rot significantly. And here's a visual of that. The black plastic, you can see the foliar symptoms of bacterial disease. On the silver plastic, so much more healthier foliage, and the cooler climate is better for bulbing and putting on size. So you get bigger bulbs. You're spending more time bulking up, and the onions are also not rotting. The biodegradable black plastic just breaks off, so it's a cooler climate. So growers are actually taking, some of them are still growing on black plastic, but they'll slit it, they'll slash it off during bulbing to release some of that heat, so they have less rot.
Hey, Christy, how about the silver for thrips? Does it suppress thrips? We've read that in several places.
Yeah, a little bit. The work that we did here, and I forget what Brian Nault's results were off the top of my head, but we maybe delayed the reaching the spray threshold by 2 weeks at the most, and then you can increase your spray interval. It takes longer for them to build up again. So it has some value. I would team it up with insecticides as a standalone. If thrips are out there, they're gonna reach above the spray thresholds, and still you could result in a yield decrease. Good question. So another study I did was looking at the space per plant, or plant spacing. So the standard practice, or the standard treatment in this trial, was 8 inches between plants, 4 rows on a 3-foot bed, so 40 square inches per plant, and then comparing that to a wider plant spacing, 10 inches, either with 4 or 3 inches per bed, so 60 or 80 square inches per plant, and then comparing that to a narrower spacing, 4 inches, with 4 or 3 rows per bed, so 24 inches or 32 inches per plant. And here we have the as we increase this the space per plant, the incidence of bacterial bulb rot increases. And from this, comparing the standard to the 4-inch spacing to 8-inch spacing, reducing to 4-inch spacing, we significantly reduce bulb rot by 66%. Here's a visual of the grower standard. You can see all the rot coming in there. Here's the wide spacing, fewer plants, even more rot. And then the narrow spacing, more plants and much more healthier foliage. Here's the yield data from that trial. So we've got significantly twice as much yield coming off of the narrow plant spacing. We've got more plants, we've got less rot. And then from the standard compared to the wider spacing, we have a significant reduction in yield. We've got less plants, we have more rot. When we look at the yield data, the bulb size distribution, the colossals versus the jumbos, mediums, and smalls, from a trial that didn't have any bulb rot, we see that as you increase the amount of space per plant, you get more colossals. And in the narrow plant spacing and the standard plant spacing, the majority of your yield is coming from jumbos, which is, I think, I know there's some growers pushing for colossals, but jumbo onions still, I think, have good value. So when we look at the data set, when we've got bacterial rot, what we see is in the colossal category that as plant spacing, or I should say as plant space per plant increases, the number of colossals decrease. And that's because the big bulbs rot. That's not to say the smaller bulbs can't rot. Well, so we'll talk about the neck in a moment, but it's related to a big plant with a thick neck being more susceptible to rot. Okay, I want to talk about this excessive leaf dieback. If you can't control your leaf diseases or your thrips, Mother Nature's just unkind, and you have onions dying standing up. I did a study several years ago where I compared onions that lodged properly to those that died standing up, and found that on average we had twice as much rot in the onions that died standing up. So remember, the neck, it's all about the neck. When they die standing up, it's like an open vessel for water, either mostly by rain or weather events, splashing soil that's contaminated with bacterial pathogens into that neck area. So new infections. Also, if you've already got rot in that onion and you're adding more rot to the neck, it's just going to drive it into the bulb. Not necessarily that it's physically driving it into the bulb, but it's creating an environment that's favorable to the disease so that it'll progress into the bulb. So one thing that we can do to prevent new infections from occurring, is to gently roll the onions so that neck is not exposed. Also, if there's already rot in those onions, but it hasn't made it all the way to the bulb, maybe by not filling the necks up with water, you're not creating that favorable environment to push the rot, or to progress the rot into the bulbs. So this is done when the onions are dying standing up, they just don't have the weight to lodge properly, but the necks are soft. So it doesn't take much to roll them down. And this is a gentle roll. We don't want to be rolling a crop that's got a lot of green tissue and snapping necks that they're not soft yet. We don't want to cause any wounding. So I did this on a small scale just with a seed bucket. It's very easy, it's very fast. growers, my large scale growers are using these plastic drums. So this is fairly lightweight. And this is easy, it's inexpensive, and I'll show you in a moment, it can reduce bulb rot. So the black bar here, so this was a trial that I artificially inoculated after the onions were rolled. And so the onions that died standing up, or were left, I should say left standing, not all of them died standing up, had 14% rot. The onions that were rolled had 57% less rot. So we brought it from 14 to 6. In another trial, we reduced the rot by rolling by 35%. So we know when onions die standing up, they can be more susceptible to new infections of bacterial disease or create conditions that's going to move the rot in the neck into the bulb. We know that when we roll them, we can protect the onions from new infections or just protect the neck from getting splashing water into it. What we don't know is if there's going to be an inoculation event. That's up to Mother Nature. But a lot of my growers have decided this is so cheap and easy, we're just going to do it. If there's no rot event, it's not that much of an investment. If there is, it could save us 35 to 57% in rot. So now, can you win the rot race? So we talked about preventing new infections from occurring. The rot race, so if you have an infection in the neck and it's not yet in the bulb, the rot race is the race to get the neck dried down, making it impassable for bacterial disease before the bacterial disease enters into the bulb. So here's some data from Washington where let's try to pull the onions early. Let's get those leaves to dry down early. So we're looking at 2 data sets that were artificially inoculated. The first set in each, the first set of bars is the bulb rot data. The second set is the yield data. The red bars are when they pulled 14 days early compared to their standard pulling. So 50% tops down, 90 to 100% green foliage. Standard pulling is 90 to 100% tops down with only 0 to 5% green foliage, comparing that to not pulling them at all. And so they were all harvested when the foliage was completely dried down. So looking at this first data set, we see that the early pulling significantly reduced bulb rot by 15 to 20% compared to the standard or not pulling at all. When we look at the yield data, that translated into a significant yield bump, so twice as much yield because we reduced the rot. However, in the other 2 treatments, we had no difference between rot, but we had a yield drag with the standard pulling of 31%. So in this case, if the onions were left in the field, they would have continued to put on size. In the other data set, we didn't see any difference in bulb rot, but we saw that early pulling, we had a yield drag of about 15%. So that's the trade-off. If you have a lot of rot, that early pulling, and if you can get those onions dried down, you could win the rot race and you could get more yield. If you don't have enough rot in the onions and you pull them early, it could be at the expense of a yield drag. So what's that sweet spot? Well, in Pennsylvania, many, many years ago, this is Beth Gugino. I forget the name of her PhD student, Emily something. So they had a severity rating of Foliar symptoms from 0 to 7. And their research showed that if you harvest when you're averaging 3 to 4, so 1 to 2 leaves showing symptoms, if you harvest at that stage, for them, that was the sweet spot between reducing bacterial rot and having the best yield. You're reaching your maximum yield potential, I guess, with rot. So if you leave the onions out longer, you're going to have more rot. So that's the trade-off there. So now moving on to harvest practices for best quality. This is obviously muck onion production. The point I want to make is when you pull the onions and you're windrowing them to leave them in a single layer, as opposed to these thick layers, because you're going to just have a lot of leaves and it's just going to take longer to dry down. And we want that neck to dry down as fast as possible to win the rot race. I also don't like to see exposed bulbs, particularly when they're pulled green, and this is in the heat of July or August, because they are very susceptible to sun scald. I would prefer if you could just lay the tops of the onion plants over top of the bulbs. So this is a plot that I harvested. And then I just wanted to point out that if you pull when the temperatures are in the high 80s or the 90s, especially if the onions are a bit green, that is more conducive to sun scald and also black mold, which looks like muck. it's favored by high humidity and high temperatures. And then sun scale can be invaded by bacterial diseases, and that can cause your onions to rot as well. So some growers are bringing their onions inside so they don't get sun scald and putting them inside a high tunnel. You can see the shade cloth over here. You want to keep the temperature below 85 and ensure good movement, air movement. We don't want to have stagnant, humid air in here. Okay, when it's time to top the onions, the greener the neck, the greater the risk of bulb rot. So when you top that green tissue, that's a wide open door for new bacterial infections, and it's wet, so the soil contaminated with bacteria is stuck right there. You're literally inoculating your onions when you're topping them green, or you could be. So here's some data from the Stop the Rot project from Washington, where they are looking at topping at different stages, so different degrees of green necks. So the first bar is a natural infection, and the second is artificial inoculation. And they are comparing topping early when the plants have 90% green foliage and the necks have 91% moisture, comparing that to their standard topping when the leaves have 5% green and the necks have 60% moisture, comparing that to when the plants have no green foliage left and the necks have 18% moisture. And you can see the difference between 91% moisture and a significant 65 to 89% reduction in bacterial bulb rot. And this is also true for botrytis neck rot, which is a fungal disease. And so here's just a visual of what the necks looked like at 90% moisture. And this is what the foliage looked like when they were topped compared to the 60% moisture and the 0 and what the foliage looked like. So even half as much green tissue is going to significantly reduce your rot compared to topping it at that time. And there's a visual of the rubbing the neck between your fingers. And if it slides like on the, I'll do that again. If it slides like on the right, it's still wet inside. And if it's the bulb is flailing around and you can't slide it, the bulb is dry. Of course, you can cut it to check, but that's the fingertip roll test. And I made a video of it, so I wanted to share. All right. Another recommendation that we have is to leave at least a 2 to 3 inch neck to win the rot race. So there's if you're topping onions green, there's the risk that you're introducing new infections, either from contaminated soil, topping the roots and topping the top, or if you're topping onions that have bacterial in the neck, you got it on your knife, now you're introducing it to a green bulb. So we want to win the rot race. So this is 2 studies out of Georgia, and when they had 0 or 1 inch neck, and I've got my schematic diagrams of neck length here. So 18% rot with 0 to 1. When you have a 2 or 3 inch neck, you significantly reduce rot to 11 or 10%, so by 30 to 44%. And the second identical trial, with 24% rot with the 0 to 1 inch neck, significantly reducing it to 10%. So 59 to 60% reduction in rot. And so when you have a new infection at inch 3 and you're drying these onions down, you're buying yourself time to dry down that neck before it gets into the bulb. If you have a little neck, it's just going to walk right in the bulb. So just a little bit about harvest practices for best quality. You don't want to be harvesting onions, or you want to be harvesting onions when the weather is dry. If you're working with wet onions, wet foliage, you're bringing moisture into the system, it's going to take longer to dry down. It's going to, it's favorable for disease, for movement of disease. If it's really wet, the bulbs can re-root, and rooting causes sprouting, so that reduces quality. You also want to avoid bruising. Bruising can be invaded by secondary rot. So just be mindful, like treat those, particularly those big, colossal sweet onions, treat them like they're gorgeous glass ornaments or something, or fine china. And just think about all the steps along the way. Are there any drops that could be causing bruising? And then I also put on here, disinfect your clippers or your toppers. I have not done this personally. I can imagine it's very tedious. However, I know that it's a way of introducing rot from an infected neck to a clean neck. So something to think about, something to consider. And then not finally, but then when you're curing, for those of you who are storing your onions, you need to cure them first. The curing process is going to dry out the outer layers so they tighten and form a papery skin that seals the bulb, performing a protective barrier from diseases and from moisture. And the neck is going to wither and seal, preventing moisture from entering. So that's packaging it up for long-term storage. The process of curing usually takes about 2 weeks after you've harvested the onions. Of course, if there's more grain, it could take more time. The optimum conditions are 68 to 86 degrees Fahrenheit and 70 degrees relative humidity. For artificial curing, so what my big guys are doing, they're heating the air temperature to 3 to 5 degrees above the ambient air temperature. So if you're harvesting when temperatures are really hot, now you're going to be dealing with a really hot system for artificial curing. And so best skin development occurs between 75 and 90 degrees. Greater than that, you get darker skin, and that's favorable for bacterial diseases. You want to avoid a greater than 82 degrees if black mold is of concern, especially if onions are on the green side. And if onions have poor skins or have been touched by frost, you want to keep the temperature below 68. And the relative humidity entering into the onion should be 50% or less. Obviously, while they're curing, it's going to be warmer than that because you're pulling the humidity out of there. But once the relative humidity coming out of the onions is similar to what went in, they're done. The airflow should be 3 cubic feet per cubic foot of product per minute. So I don't know what level you guys are curing your onions on a small scale. I'm just telling you what the optimum conditions are. So the closer you can get to this, theoretically, the better quality of the onions you will have, and the longer term you can store them. Another thing to consider is use crates, boxes, and bins with slots to allow for good air circulation. In shallow depth, the shallower the better. Again, it's more airflow drying down those leaves. Smaller onions, there's less movement between or airflow among the onions. And feel free to monitor the temperature and the relative humidity and figure out what's going on. Is this optimum or is it not optimum? And what can you do to alter that? Large scale production, the majority of onions are being cured outside. There's not a lot of artificial curing. It works. And then I just wanted to share with you a study I did with artificial forced or fast curing with heated forced air. I was trying to win the rot race. So here was the situation. I had a field where we had 79% of the plants had foliar symptoms of rot. When I cut open those bulbs, in 81% of the cases, the rot had not got into the bulb yet. So those 19% that already had a bulb infection, there's nothing you can do about that. Unfortunately, we can't push that out of the bulb. I wish it would go the other way. We can't do that. But I'm like, oh my gosh, there's like so many plants in here that maybe we could prevent the disease from getting into the bulb. So what I did was I harvested them at that time, I topped them, and I put them on a drying wall with artificial forced air. They were on the drying wall for 10 days. Oops, I'm going the wrong way. And so this just shows the difference in the temperature in red in the drying wall and the relative humidity on the drying wall in red compared to in the field in gray. And so this was for 10 days. And in the field, I either pulled the onions or I left them as the grower would have left them. So I had a pulling early treatment in there as well. So the conditions on the drying wall were warmer and drier with less fluctuations than field conditions. And you can see here the less fluctuation compared in the drying wall compared to the natural curing. And here's the results of that trial. So looking at percent bulb rot, so we started with 19%. And so the grower ended up with 23% rot. So did he win the rot race anyway, or were they strains of bacteria that couldn't live in a bulb anyway? I guess we'll never know because we never collected the samples of rot and identify and figure out what it was. Anyway, the purple is pulling early. So that didn't really make much of a difference compared to the grower standard. He ended up pulling 2 weeks after I did. They ended up drying down very similar. Like I only harvested 5 days before he did. So there wasn't really much difference between those treatments at the end of the day. But here's my trying to win the rot race with heating them up on a drying wall. I increased the rot significantly by 36% from 23 to 32. And of course that resulted in a little bit of a yield drag. So why did I lose the rot race? Well, what did I do? I topped those onions when they were green. I didn't sanitize my knife. I introduced new infections with soil that was contaminated with bacterial disease, and then I heated them up. What is bacteria like? Hot. So yeah, I think I mean so that's not the solution to win the rot race. So that was a good lesson. And then finally, optimum storing conditions for those of you who are trying to store your onions longer term. They're 32 to 34 degrees Fahrenheit with 65 to 70 degrees relative humidity. I have lots of growers storing in the 40s, like 40 to 45. The warmer the temperature, the less time they will store. And you want to bring the temperature down slowly. So if you're drying in a high tunnel, if you're curing in a high tunnel and you do have refrigerated storage, you don't want to just go from 80 degrees to 32 degrees. You want to bring the temperature down slowly, or else they'll be sweating. You bring humidity into the system. Also, you want to protect your cured onions from direct sunlight because that can cause greening. And some growers are pre-grading, sorting out the rots. Because a rotten onion is going to have moisture, you're bringing moisture to the system, and also they can rot and stain other onions, and yeah, just get them out of there. Store your best quality onions, not your rotten onions. So I don't know what time it is. I have reached the end of the line. Oh, 12:46. Perfect. So yeah, happy to answer any questions you may have. Do you want me to stop sharing my screen?
Sure, unless, yeah, people
I
might
can
want to
bring
see.
back another.
Thank you. That was amazing. I couldn't take notes fast enough, so
Yeah.
I'm glad we're
I know.
recording this.
I know. Yeah. So there's
There's
definitely some tips in there to stop the rot.
Yeah, it's amazing. Couple questions in the chat to start
Mhm.
with. First question's from Caleb. I don't know if Caleb, if you just want to unmute and ask, or I can read it for you.
Sure. So a lot of growers use multiple plants. They'll group 2 or 3 together.
Oh, gotcha. Per hole,
So
per
I'm just
cell.
curious, yeah, how if you have a theory on why the closer planted singles had lower incidence and how that might play out with maybe, what kind of spacing would you do if you were planting 3 at once?
Okay. So your observation has been when you have multiple plants per hole, let's say, that you have less rot?
No, I work with a lot of growers, and many of them do that just because they'd rather plant 3.
Oh, okay. Okay. Yeah, I was like, if you had that observation, I'm like, that actually makes sense because there's more competition in that small space, and they're probably going to have smaller necks and mature earlier and win the rot race that way, or not get infected to begin with and win the rot race that way. So I've done a bunch of, you're digging back here. I've done a bunch of trials with spacing and having multiple plants per cell. And when I put 3 in a cell, I often got 2 mediums and a small, or 2 smalls and a medium, versus, so say I did that with 8-inch plant spacing, and I compared that to 4-inch plant spacing with a single plant per hole, more consistently larger bulbs, because when you've got 3 in a cluster, they're really competing for the nutrients and the sunlight in that small space. So I think my planting density, like going for jumbos, the 4-inch spacing is like, if you want a 4-inch onion and you give them 4 inches, they'll take it, but you have to ensure that there's no limiting factors with nutrients or water. Like it's got to be a fairly well-run system. So I'd rather almost do 6-inch spacing and then 8 inches between the row. I'd prefer to give them a little more spacing between the plant. So what is that? What's that work out? If you've got per plant, 6 by 8 is 48 inches per plant. And then, so if you've got 3 plants per hole, what would you want your plant spacing to be? I don't know. I'm kind of tired. She's doing the math right now, but is that kind of a fair? Am I a roundabout way getting to your answer? Like aiming for about 48 inches per plant when you take your.
Yeah, I think just sort of that trade-off between
Yeah.
bulb size and neck size, I think it's really getting to the point of,
Yeah, and it depends what your market is. If you're really trying, like, if you're trying to get colossals and jumbos, I certainly wouldn't be putting 3 in a cell. If you're going for size, I would only put 1, and you might be able to get 2 jumbos with 2 in a cell. And it depends on other factors as well. Irrigating, do you have 2 drip line? Like, how many rows per bed? Do you have 2 drip lines or 1 drip line? Are they getting enough water? Are they getting enough nutrients?
Christy, I guess just to follow up on that, then, like, if you think you could achieve the average plant density that you have like come up with, even with like 2 plants per cell, you think you would achieve like a good average bulb size that way?
With 2?
Yeah.
I would think so. Like I said, as long as there's no limiting moisture
Yeah.
or nutrients. 3 per cell, I think, is going to be great for, majority mediums, maybe 50% mediums, 30% jumbos, some smalls, maybe some. I don't know if you could get colossals out of that, but
Wouldn't want colossals.
Would
Couple
you-
more questions in
Yeah.
the chat. Heather, again, you're welcome to speak, but Heather Bryant was asking about if you're concerned about rot, but you also had allium leaf miner and leek moth. Would you still recommend leaf rolling?
Okay, so allium leaf miner so here it would be only so leaf miner is active in April, then it takes the summer off and comes back again in September. So in onions, like our direct seeded crop is free, but it could affect early transplants at the tail end of April. And then, although I guess I've seen them in the fall in onions as well. So Heather, do you have leaf miner in your onions?
So I have I also work with farms,
Oh.
Caleb, and so I had a client this year who had bulb rot for the first time, and they also had, and I can't remember if it was allium leaf miner or leek moth, but it was probably both this past season because they've had both in the past. And so just in terms, they're a no spray farm, so in terms of like, things they can try this coming season, I was wondering if leaf rolling was something that might work for them, or if it's likely to backfire if they get either of those 2 insects again this coming year, which chances are they will.
And then leek moth is like diamondback moth, which causes foliar issues to the leaves. Does it end up contaminating the bulbs?
I think they both lay the eggs on the leaves, and then the eggs hatch and they go down towards the bulb. But somebody on the call can correct me if
I'm sure I've seen allium leaf miner, secondary rot chase allium leaf miner. So so if you're rolling your onions, I think the insects are going to do what they're going to do. So how would it make those pests worse?
don't know. That's what I'm asking you.
Okay. My first thought is it's not going to matter. The insects are going to do what they're going to do.
Yeah, and that might be a good question. We're gonna have Vic Izzo on, and he's been looking a lot at kind of like post-harvest management of leek moth. So that might be a good follow-up for him. Or yeah, a future research project for
Okay,
you to see.
Both of those insects are moving their way down from the plants through the neck into the bulb.
I believe so.
So I don't think rolling is gonna trap them above, like, it's not gonna trap them in the leaves. They're still gonna move because I think they're gonna do what they're gonna do. Maybe you're protecting from secondary rot a little more.
It seems like the rolling won't hurt, like wouldn't make anything worse on the insect side and helps prevent the rot. So still,
Yeah, yes, I guess that's what I'm thinking. Like it's not gonna make the insect problem worse. Or at least right now, I can't think of why it would, but
Well, maybe this farm would be willing to do a little test. Roll some and don't roll some and see if it
for
makes
for the insects or for the rot or everything.
the rot.
Oh, okay. Yeah, you're like, maybe you should try rolling to reduce your rot problems, and it shouldn't have any effect on your insect problems.
That's what I'm wondering.
Yeah. Okay.
So another question on newer organic insecticides, Grandivo for thrips. Have you looked at that at all, or do you have any data? This Allie says they think they've been seeing good results.
Okay. Off the top of my head, I cannot remember if Grandivo was in that trial. What's the active in it?
It wasn't in the slide, I don't think.
No, I didn't present all the data. I just
Oh, okay.
put the highlights in. So it didn't make, so I can't remember if it was in the trial or not. If it was, it didn't end up making the cut for a recommendation.
Just Chromobacterium is the active in it. No.
I mean, I can dig really, I can see if I can find it quickly.
Anyone else? Caleb, do you have any experience with Grandivo on onions? Anyone else?
Okay, I did find the presentation, so let me just see quickly if it was trialed. No. So what was in the trial was Azera, which is a premix of azadirachtin and pyrethrin. Entrust I mentioned, Nemix I mentioned, and then this product called PFR 97 20% WGG, which is a Certus product, Iseria fumosoria. Is that what you were talking about?
Not sure. Allie, do you want to chime in?
Was it a biological Grandiva? So the active in this other product was Azaria fumosorisa. Sorry, I'm botching the pronunciation. Which did.
Hey, thanks, Christy. Grandivo is something different than the PFR. I have seen that. We haven't used it. I'm just wondering.
Okay.
Seems like there's supposed to be good for soft-bodied stuff, and it seemed like we were getting some impact. I'm just thinking of other options for that rotation with
Right.
Certainly we have concerns about the resistance development. So
I appreciate that. So for whatever reason, they did not trial Grandivo in this trial, and I don't know why it did not make the cut.
it is relatively new, I think, last 3 to 4 years, maybe. So.
Okay. Right now. I
Well, thank you. That was great presentation to hear all the info. So.
Thank you.
Last questions from Vern, which could be another talk into itself, but any guidance on nitrogen fertilization and effects on disease?
Oh, so we've done a lot of work trying to tie timing of fertilizer. The Stop the Rot project did timing of nitrogen, rate of nitrogen, whole bunch of studies, and I think maybe in Georgia they got some hits on when they're working on the sand, and they're what am I trying to say? They're applying it throughout the season. They're banding it on throughout the season. In New York, we're front loading it for the majority. In New York, we did 11 nitrogen studies. Some of them for thrips, some of them were for rot. This is all on muck. And in one trial, we found that nitrogen made a difference for bacterial rot, and it was the difference between 0 and 50 pounds per acre. So Nothing makes it, nothing makes a difference, but 50 all the way to 150, there was no difference in rot. Earlier on, like 2009 to 2010, I was working, that Pennsylvania study that we had more, or we had less rot. Our trial was kind of on a little bit of a slope, and as we went down the hill, we had more and more rot, and we thought, oh, the nitrogen moved down the hill from the top to the bottom, and we had more rot on the bottom of the hill. And I had one trial in New York where we saw, as you increase the rate of nitrogen, that we got more rot, but the increase was from something like 60 pounds or 75 pounds to 100 or more. It's somewhere, like, for the most part, the rate that growers are using, and onions are such heavy nitrogen feeders, and they've got such poor root systems. You have to put on more than they actually need so they get enough. So within the rates that growers are using, we really didn't see any effect on bacterial rot. And no difference in thrips for all those studies that the entomologists did. I don't, off the top of my head, I can't think about any of the leaf diseases.
That
So
sounds,
I feel like use what you need to get that crop where you want it, so it's healthy. And unfortunately, if it doesn't take it up, then it's so hard to time the so onions use 75% of their nitrogen during bulbing, which is a fairly short window. And before that, I think like up to the 4-leaf stage, they only use like 3 to 5% or something like that. So you're front loading your nitrogen. The crop is not using much, so there's an opportunity to leach it then, or for it to leach then. Then you want to ensure that you have enough during bulbing. So some growers side dress at that point, but then you don't want to have too much nitrogen left over after bulbing, because it can encourage vegetative growth, which delays the maturity, and then the thick necks, stiff necks, stuff like that. And then if you don't have it, nitrogen moves with water. So if you don't have the moisture to follow or to move the nitrogen, it could be sitting there, then you get a rain, then you get a burst of nitrogen. So it can be a little bit bumpy, I guess is what I'm saying. It's kind of tricky to get to hit it perfectly right. So I think what we're seeing is growers are over fertilizing to ensure that there's never a time where the crop is suffering from nitrogen, which is at the expense of leaching, and that crop will leave a lot of nitrogen behind. So for us, we're putting on cover crops to slurp it up, scoop it up, use it up, and then hopefully they'll drop it off in the spring for us, so we can count on having some nitrogen there in the spring. And so for a sweet onion harvest that's in July, I don't know what you want to put after that, but just know onions are going to leave nitrogen in the soil if you've given them the proper nitrogen. Long run on answer.
no, that's great. I could listen all day. So many things to learn about onions. But we're gonna stop with respect to time here.
Okay.
Thank you so much. Unless other people have last minute questions, we can hang on for a few minutes. But thank you so much, Christy, and thank you, Anne, for organizing